So let me draw a line L, and let's say the line L has a known point P naught on it, and P naught is X naught, Y naught, Z naught. And let this line L have any arbitrary point X, Y, Z. So let this line have any arbitrary point X, Y, Z. And let's say also that the direction of the line is represented by the vector D, where D is equal to A, B, C. All right. So for a point P, X, Y, Z to lie on the line, we must have vector P naught P be a scalar multiple of D. So in this equation, T belongs to the set of real number. So we can expand this, and this becomes X minus X naught, Y minus Y naught, Z minus Z naught is equal to T times A, B, C. And we can further rearrange the terms. So it takes the form of X, Y, Z is equal to X naught, Y naught, Z naught plus T times A, B, C. All right. So this is the equation of a line that has a point X naught, Y naught, Z naught, and the direction of that line is given by the vector ABC. So let's take an example. So let's say if I wanted to find the equation of a line that passes through, say, point -1, 0, 3, and let's say it's in the direction of 3, 4, 5. Okay, so quite simply, using the result above, the equation of the line will be X, Y, Z is equal to -1, 0, 3 plus T times 3, 4, 5. All right, and here T is a scalar, so T belongs to the set of real numbers. Let's take another example. Okay, so let's say I wanted to find out the point of intersection between the plane X minus 2Y minus Z is equal to 0 and the line which is given by the equation XYZ is equal to, let's say, 1, 0, 0 plus T times 1, 2, 2. So I wanted to find the point of intersection between this plane and this line. So looking at the equation, we can find out that the normal vector to the plane is 1 minus 2 minus 1, right? And the directional vector of the line is 1, 2, 2, right? So let's try to find out the dot product of N and D, and it will be equal to 1 minus 4 minus 2, right? So this will be -5, and this is not equal to 0. It means that N and D are not perpendicular to each other. It definitely means that our line will intersect the plane at some point. All right, so that was the first thing that we established here. And now that we have already established this fact, using the equation of the line, we can substitute X is equal to 1 plus T, Y is equal to 2T, and Z is equal to 2T. So Y is equal to 2T and Z is equal to 2T in the equation of the plane, which is X minus 2Y minus Z. So doing that will give me is equal to 0, and I think you can find out T from here. So T will be 1 by 5, which is 0.2, right? So therefore the line intersects the plane at X is equal to 1 plus T, which is 1.2, Y is equal to 2T, which is equal to 0.4, and Z is 2T, which is equal to 0.4.